one. So I decided to do number 4, I believe, which was Entropy and Gibbs explain how the first, second, and third laws of thermodynamics apply to chemical and physical processes. So, to begin with this, I'd like to kind of break through each one and kind of what entropy and Gibbs is, and then lastly, all 3 of the thermodynamic laws. So first, what is entropy? Entropy is the measure of a system's thermal energy per unit of temperature. So depending on the amount of work that is gained from the ordered molecular motion, entropy is what we use to measure the amount of molecular disorder. So what I like to think of is kind of entropy is the law of disorder. So like chaos, disorder, those two kind of go hand in hand. But it also applies kind of to the Gibbs free energy, which something that I find really helps me understand it is to the equation that goes with it. So delta G is the Gibbs free energy. It's the symbol. The delta G is what it is. Delta H is the change in enthalpy. T is the temperature, which we like to use in Kelvin, so K. And then delta S is the change in entropy. So now that we've gone over those two, I'm going to break down kind of the thermodynamic laws. So the first law is pretty simple. It's the law that means that energy cannot be created or destroyed. So since energy cannot be created or destroyed, instead of trying to do that and all that mess, we can actually transfer that energy throughout a system or the surroundings by using heat. So a good equation for this is that delta E equals Q plus W. So to break that down, Q is the amount of heat, energy, plus W, which is the total amount of work that is needed, and these two must be equal to delta E, which is the total internal energy change. Next, what is the second law of thermodynamics? So out of all 3, this one is the more important one. And I found that there were about 3 or 4 different ways to kind of help explain what this one is. But the one that I found was a little bit easier to understand and explain is that for a spontaneous process, the entropy of the universe increases. So a good example of this would be that heat just doesn't spontaneously flow from a colder object to a warmer one. And then lastly, the third law states that a perfect crystal at 0 Kelvin has 0 entropy. So, to begin with this one, just to kind of give a little bit more explanation, when we say a perfect crystal, we mean one that has no impurities. So like no dirt, no chips, no nothing. It's pretty much perfect. And it has also achieved perfect thermodynamic equilibrium, and that the state that where we find it has all atoms, ions, and molecules. Those 3 are in good positions within the crystal. And personally, out of all 3 of these, this law is kind of my favorite. But all 3 of these laws are always connected to chemical and physical processes, no matter what. So no matter the lab that we are doing, no matter whatever everyday thing that we're doing that involves science, which pretty much everything, these laws are currently always, no matter the situation, these are always in place, and they're always in play. So thank you.